In lab, you guys used a cart motion detector to examine what happened to a cart when a hanging mass pulled on it and dragged that cart along a track. And what you noticed was as the hanging mass was falling through the air, gravity was pulling on it, and that pull accelerated the cart. But as soon as the hanging mass hit the ground, the cart stopped accelerating. That doesn't mean it stopped moving. It moved at a constant speed, but it stopped accelerating. It stopped getting faster. And essentially, that's what Newton's first law is. And we have a word for that. Okay, we call it inertia. Inertia is the tendency of an object to resist a change in motion. It's important that you remember that word change. Objects do not resist motion. If an object is in motion, it's going to remain in motion, and it'll continue moving in a straight line. An object at rest will remain at rest, but it does not want to change its motion. So inertia is the tendency of an object to resist a change in motion. Now, we had several different cases on that cart that you guys examined in lab. We had balanced forces, unbalanced forces, and then balanced forces again. So when two equal sized forces act in opposite directions, they cancel out, and we say that those forces are balanced. And if the forces acting on an object are balanced, they don't affect the motion of the object. So you guys saw that in two different places. Initially, you had the cart resting on the track. There was a string coming off of it, and that string was connected to a hanging mass. So we had some kind of setup like this. Now, there are forces acting here. We had the force due to gravity acting down. We had the force that the track was exerting on the cart acting up. Then we had the force from the hanging mass acting in the string, pulling it this way. But you were also pulling on it. We had the force from your hand pulling it back. And all of those forces are balanced. That means you're pulling backwards as hard as the string is pulling forwards. The table's pushing up as hard as the gravity is pulling down. And this thing was at rest, and it remained at rest. Nothing about that changed until you let go. Then we took off this force. All of a sudden, this force isn't here, and now these forces are unbalanced. Okay, the table and the track and gravity are still balanced. They're still not doing anything, but the string is all of a sudden unbalanced, and now all of a sudden this cart started to speed up, moving in the same direction, accelerating in the same direction as that force. And that allowed this hanging mass to fall until this hanging mass hits the floor. Now, as soon as this hanging mass hits the floor, gravity is pulling down on it, but the floor is pushing back up, and that means that the string doesn't have to pull on it anymore, and that means there's no force in the string anymore. And that means all of a sudden this force is gone, and now the only forces acting on my cart are gravity and the table, and it's stopped getting faster. It stopped accelerating. So when we have balanced forces acting on something, they don't cause change. When unbalanced forces act on an object, the object accelerates. Balanced forces cause no change in motion. They cause no acceleration. Unbalanced forces are forces which don't cancel, and they do cause a change in motion. They cause an object to accelerate. Now remember, accelerate doesn't mean speed up. Accelerate means speed up, slow down, or change direction. It's the rate of change of velocity. Okay. Now, we put all these things together and we get Newton's first law of motion, which is sometimes called the law of inertia. Newton's first law of motion is not an object at rest remains at rest and an object in motion remains in motion unless acted upon by an outside force. I hate that. Okay, you guys all memorized that when you were in third grade and you never stop and think about what it means. So I have a different statement of Newton's first law of motion. I say that the velocity of an object remains constant unless an unbalanced force acts on the object. Hopefully that puts in your mind that we are talking about change in velocity. We are not talking about motion. So Newton's first law, the law of inertia, states that an object's velocity remains constant. If it's in motion, it's going to keep moving with the same speed in the same direction unless you force it to change. Some outside unbalanced force has to force it to change. This is essentially inertia. So I want you to remember, forces do not cause motion. They cause a change in motion. That's to say, forces cause acceleration.